we'll be taking up the section formula today under coordinate geometry. What happens under coordinate geometry in section formula, that you get a direct question. The first and foremost application I can say that you are given a line, the coordinates of the points joining to form this line is also given to you, and a ratio is given in which this m1 and m2 in which AB is getting divided, suppose by a point called P, and you have to find the coordinate for the P. We'll just take a converse of this problem, wherein you are provided with the coordinates of the point P and we have to calculate the ratio, which is m1 and m2. To do so, just let me write the question on the board. The question says, find the ratio. You can skip that E of the second word there. I just skipped it so as to I can write a little faster and put the question on the board, in which the point 2, 1 divides the join of the points 1, -2 and 4, 7. So if you look at the figure which I had drawn previously, this point is for P. P is given to be 2, 1. Let us consider this to be A and this to be B. You can though take any of them either as AB. So let me just write it down as 1 -2 here, and this becomes 4, 7. We here needs to apply the section formula to find the ratio m1 and m2. To do so, let us assume that let the required ratio which we are supposed to actually calculate be k is to 1. K is to 1. This one is referred to as my m1 and this being referred to as the m2. Now what do our section formula says? It is m1 x2. Do I need to write it again? Let me. m1 x2 plus m2 x1 by m1 plus m2. That gives us the x coordinate, and the y coordinate is given by m1 y2 plus m2 y1 by m1 plus m2. That means this is the x coordinate of P, which is equal to 2 in our question, if you see, and the y coordinate is given to be equal to 1. Let us now replace or substitute them in the formula. m1 is k, x2, I need to write down for our convenience, this is x1 y1 and this is x2 y2. So it is m1 is k with x2 is 1. Is it not that clear? Let me make it. K and 1 plus m2 was 1 and x1 is 1 by m1 plus m2. That was m1 plus m2 being 1. On the other hand, m1 is again k with y2 given by 7 plus m2 being 1 and y1 is -2 by again k plus 1. This is k plus 1. This is m1 x2 is 4. So it is 4k plus 1 by k plus 1. This is the x coordinate which is equated to P in 2, 1. So I equated it with 2. Similarly, the y coordinate is 7k minus 2 by k plus 1 equated to 1. Let us quickly solve it and find k. From the first equation, let me take up, means this one I refer to. So 4k plus 1 is equal to 2k plus 2. If you solve it, you are getting, if 2k is brought to the left, I am getting a 2k, and 1 again moved to the right is giving me 1. So k is calculated to be 1 by 2. As I had already assumed or taken my required ratio as k is to 1, the ratio can be now represented as half is to 1. Or if we represent it better, multiply both of them by 2, I get a 1 is to 2. So this is the required ratio of m1 is to m2 in this question. Now I move on to another part. See, the previous question which we discussed where bisected, the line was divided into 2. Now let us take up a question wherein the line is divided into 3. So this is suppose this is suppose A and B, the line joining the points joining to make a line, and now these 2 points which is given by P and Q. P and Q are dividing AB in 3 various sections. Suppose this is, I refer to as 1, this is 1, this is 1. Why? Because they are equally dividing, trisecting. Let me just take up a question. I need some time to write it down and then we discuss it. Find the point of trisection of the line segment. I would use the same figure actually which I had made to explain the trisection part. The points, it's 1, 2, that means these are the points. If you equate it to the figure, becomes A, B. Okay, we have to find the points which says it is P and Q. So this A is given by, suppose 1, 2, and this is given by 11 and 9. We have to find PQ's coordinates. Let me take up that AP is equal to PQ is equal to QB given by K. In such case, AQ is equal to AP plus PQ, which can be written as K plus K, which I had actually assumed them to be. So it's giving us 2K. On the other hand, if I am taking PB, which is giving PQ plus QB, the both again to be K plus K, which is 2K. So what do we find? AP is to PB is 1 is to 2, because K is to 2K, that's giving us 1 is to 2. On the other hand, AQ is to QB. AQ, if you see, is 2K. This is 2K. Is to 1K, that is QB. So it is again 2 is to 1. Now P is dividing, this P is dividing AB internally in the ratio 1 is to 2, and Q is dividing AB internally in the ratio 2 is to 1. I'd rather put this up on the board. P divides AB internally in the ratio (1:2), and Q divides AB internally in the ratio 2:1. Okay. Now what are the coordinates of P? The coordinates of P will be, I will be applying the section formula. So P, suppose, has got this ratio 1:2, so I'll assume this to be M1, this as M2. On the other hand, this one will be x1 y1 and this becomes x2 y2. If you recall the formula, it is given by m1 x2. So it is m1 into x2 plus m2 into x1 by m1 plus m2. Secondly, the y coordinate will be given by m1 into y2 plus m2 into y1 by m1 plus m2. So that's giving me 11 plus 2 by 3, and here it is 9 plus 4 by 3. So the coordinates of the point P, which is dividing AB internally, is 13 by 3 and 13 by 3. We will take up the Q coordinate now. So the Q coordinate says it is M1. Now our M1, M2 will be this one because we are taking Q coordinate. So this is our M1 and this being the M2. So M1 x2 plus M2 x1 by m1 plus m2, and the y coordinate will be m1 the y coordinate will be m1 y2 plus m2 y1 by m1 plus m2. That's giving me some 22 plus 1 by 3, and here it is 18 plus 2 by 3. That finally becomes 23 by 3 and 20 by 3. So this one is the coordinates of P, which is dividing AB internally in the ratio 1:2. On the other hand, this one is the Q coordinates, which is dividing AB internally in the ratio 2:1. Thank you.